Good morning. So 909. I think this third problem is over. Anyone please unmute and respond. Is this the last problem we discussed in the previous class? Problem number 4. Did we discuss this problem in the previous class? Problem number 4. Anyone please respond. ಈ ಪ್ರಾಬ್ಲಮ್ ಆಗಿದೆಯಾ?
ನೋ ಸರ್, ಅರ್ಧ ಆಗಿತ್ತು, ಮಾಡ್ಬೇಕಿತ್ತು.
ಓಕೆ, ಹಾಫ್ ಆಗಿದೆ. Okay, then let's start with this problem only. In a test on electric bulbs, it was found that the lifetime of a particular brand was distributed normally with an average life of 2000 hours and standard deviation 60 hours. This is the first statement. Using this first statement, we can construct standard normal variate Z, which is given by x minus mu divided by sigma. And this mu is specified here, given here. Distributed normally with an average life of 2000. Therefore, we take mu is equal to 2000. X minus mu, x minus 2000 divided by sigma standard deviation is 60 hours. This is standard normal variate denoted by Z, given by x minus mu divided by sigma, where mu is 2000 and sigma is 60. If a firm purchases 2500 bulbs, find the number of bulbs that are likely to last for more than 2100 hours. That means in the first case, P where x is greater than 2100 is required. This is to be determined now. If x is equal to 2100, what will be the corresponding value of Z? If x is equal to 2100, Z is equal to 2100 minus 2000, that is 100, divided by 60 is equal to 1.67. 1.67. Therefore, writing P where x is greater than 2100 is same as writing P where Z is greater than 1.67. X greater than 2100 is same as writing P where Z is greater than 1.67. Now this 1.67, Z greater than 1.67. Let's mark this area. This is Z is equal to 0 and this is the curve, and this curve is always symmetric about this line. Z is equal to 0. Therefore, area on right hand side must be same as area on left hand side. Therefore, this is half of the area and this is half of the area. Half of the area on right hand side and there is half of an area on left hand side. And required is Z greater than 1.67. This is a positive quantity. Therefore, it comes here. Z is equal to 1.67. This is the area where Z is less than 1.67 and this is the area where Z is greater than 1.67. And this entire area on right hand side is equal to half, 1 by 5. Therefore, 1 by 5 minus this unshaded area will give you this shaded area, right? Half of the area under the curve minus this unshaded area will give you this shaded area. Therefore, this can be written as 0.5, this area minus this unshaded area. Unshaded area takes values from Z is equal to 0 to 1.67. Z is equal to 0 to 1.67. Therefore, this is equal to 0.5 minus, this is denoted by phi of 1.67. Phi of 1.67. This is equal to 0.5 minus phi of 1.67. This is given by the table 0.4525. This is equal to 0.525. We obtain this value by using the normal distribution table. And 0.5 minus 0.4525 is 0.0475. This is the probability for any bulb to burn for more than 2100 hours. And how many such bulbs are there? Totally, there are 2500 bulbs considered. 2500. Therefore, required is 2500 into this probability, that is 0.0475. This is equal to 118.75, and this is the number of bulbs. Therefore, this cannot take a fractional value, approximately 119 bulbs. If this is 0.5 and more than 0.5, approximate it to next number. Otherwise, you keep this 118 as it is. Clearly, 0.7 is more than 0.5. Approximate it to next whole number, that is 119. And this phi of 1.67 is obtained by using the table 0.4525. Many times that value will be specified in the question only. Next, second case, less than 1950 hours. Z remains same. Z is equal to x minus 2000 divided by 60. Now, what is required? P when x less than 1950 is to be determined. P where x less than 1950 is to be determined. What will be the value of Z when x is equal to 1950? When x is equal to 1950, this is equal to 1950 minus 2000, that is minus 50 divided by 60. It is minus 0.83. Minus 0.83. Therefore, writing the probability where x less than 1950 is same as writing the probability where z less than minus 0.83. Minus 0.83. Therefore, probability where z less than minus 0.83 is equal to probability. Now, just multiply this inequality by the negative sign. The inequality will be reversed. Therefore, writing P where z less than minus 0.83 is same as writing P where z greater than 0.83. Z greater than 0.83. Now mark this area. Mark this area. Z greater than 0.83. This is positive side of Z and this is negative side of Z. And the area under the curve is symmetric about this straight line. Z is equal to 0. That means area on this right hand side is same as area on this left hand side. Therefore, this is half of the area under the curve. This is half of the area under the curve. And Z greater than 0.83. 0.83 will come somewhere here. 0.83, that is equal to 0.83. This is positive quantity. This is the area where Z is less than 0.83 and this is the area where Z is greater than 0.83. This area is required. This is to be determined. Therefore, this shaded area is given by 0.5 minus this unshaded area. 0.5 minus this unshaded area is from Z is equal to 0 to Z is equal to 0.83. This is equal to 0.5 minus, this is denoted by phi of 0.83. And this value can be obtained by using the table. It is 0.2967. 0.5 minus 0.2967 is 0.2033. So take calculator and verify. 0.5 minus 0.2967 is 0.203. This is the probability for any bulb to burn for less than 1950 hours. And how many such bulbs are there? 2500 bulbs are there. Therefore, multiply this by 2500, which is equal to 508.25. 0.25 is clearly less than 0.5. Therefore, approximate to previous number, that is 508. If this decimal place is greater than 0.5, approximate it to 509. If it is less than 0.5, you approximate it to 508. Next, third case. What is third case? Between 1900 and 2000 hours. Between 1900 and 2000 hours, 2100 hours. Z remains same. Z is equal to x minus mu divided by sigma, and required is probability when 1900 less than x less than 2100. This is the expression for Z, x minus 2000 divided by 60. If x is equal to 2900, what will be the corresponding value of Z? When x is equal to 1900, this is 1900 minus 2000, that is 100, minus 100 divided by 60. It is minus 1.67 approximately. When x is equal to 2100, this value, Z is equal to 2100 minus 2000, that is 100 divided by 60, approximately 1.67. Therefore, writing the probability P, 1900 less than x less than 2100 is same as writing P, where minus 1.67 less than Z less than 1.67. 1900 less than x less than 2100 is equal to P minus 1.67 less than Z less than 1.67. Both are same. Now mark this area. It lies between Z is equal to minus 1.67 and 1.67. Probability where minus 1.67 less than Z less than 1.67. Mark this. This is positive side of Z and this is negative side of Z. Area under the curve. This is half of the area under the curve, that is 0.5, and this is also half of the area under the curve, that is 0.5. And this goes up to plus infinity and this goes up to minus infinity. Minus 1.67 to 1.67. Minus 1.67, it comes somewhere here, and Z is equal to 1.67 will come somewhere here on right hand side of this straight line here. And this area is same as this area. Now this probability where minus 1.67 less than Z less than 1.67, you just divide this interval into two subintervals. First interval is from minus 1.67 to 0, minus 1.67 to 0, plus 0 to 1.67. You split this interval into two subintervals. Minus 1.67 to 0 first interval, and second interval is from Z is equal to 0 to 1.67. And this first interval can be written as P minus 1.67 less than or equal to Z less than or equal to 0 is same as 0 less than or equal to Z less than or equal to 1.67. By multiplying this inequality by a negative sign, you can reverse the inequality. Less than becomes greater than and greater than becomes less than, and this probability remains unchanged. Now P from 0 to 1.67 plus P from 0 to 1.67 is twice P from 0 to 1.67. Therefore, this is equal to 2 into P from 0 to 1.67 is same as phi of 1.67. And this is equal to 2 into, by using the table, you can obtain this value. Phi of 1.67 is 0.4525. And clearly this product is 0.905. This is the probability for any bulb to last for more than 1900 hours and less than 2100 hours. And totally there are 2500 such bulbs. Therefore, multiply this quantity by 2500. You get 2500 into 0.905, which is equal to 2262.5, which can be approximated to 2263. So make a note of this. For your doubts, you can unmute. Next problem. The marks of 1,000 students in an examination follows a normal distribution with mean 70 and the standard deviation 5. This is first statement. Mean means mu is equal to 70 and the standard deviation, that is sigma, is equal to 5. Now standard normal variate Z is given by x minus mu divided by sigma, where mu is equal to 70 and the sigma is equal to 5. Z is equal to x minus 70 divided by 5. This is what we call standard normal variate, or SNV. Find the number of students whose marks will be less than 65. First case. Less than 65. That means P where x is less than 65 is to be determined. P where x is less than 65. What will be the value of Z when x is equal to 65? What will be the value of Z? This is 65 minus 70, that is minus 5. Minus 5 divided by 5 is minus 1. Therefore, writing P where x is less than 65 is same as writing P where Z is less than minus 1. Both are one and the same. P where x less than 65 is same as P when Z less than minus 1. Therefore, Z less than minus 1 is equal to, this can be written as Z greater than plus 1. Both are same. Z less than minus 1 is same as Z greater than plus 1. If you multiply this inequality by a negative sign, the inequality will be reversed. Z greater than plus 1. Now mark this area where Z takes values which are greater than 1. This is Z is equal to 0. This is positive side of Z and this is negative side of Z. This is half of the area under the curve. This is half of the area under the curve. Z greater than 1. Z is a positive quantity. It comes somewhere here. Z is equal to 1. This is the area where Z is less than 1 and this is the area where Z is greater than 1. Greater than 1. And this area is obtained by subtracting this unshaded area from this 0.5. Therefore, Z greater than 1 is equal to 0.5 minus this unshaded area, which is probability from Z is equal to 0 to Z is equal to 1. P from 0 to 1. Therefore, this is equal to 0.5 minus, this can be written as phi of 1. Phi of 1. Therefore, this is equal to 0.5 minus table value of phi of 1 is 0.3413. 0.5 minus 0.3413 is 0.1587. This is the probability of any student to score less than 65 marks. How many such students are there? 1,000 students. Therefore, required is 1,000 into 0.1587, which is 158.7. 0.7 is more than 0.5. Therefore, approximated to 159. 159. This is first case. Next, second case. What is second case? More than 75. More than 75. Z remains unchanged. Z is equal to x minus 70 divided by 5. Required is P where x is greater than 75, more than 75. X greater than 75. If x is equal to 75, what will be the value of Z? 75 minus 70 is 5. 5 divided by 5 is 1. Therefore, writing P where x greater than 75 is same as P, where z greater than 1. Because when x is equal to 75, z is equal to 1. Therefore, P where z greater than 1. This is same as previous case. Mark this area. Z greater than 1. This is z greater than 1. And this is half of the area under the curve. And again, this is half of the area under the curve. Therefore, z greater than 1. This area is obtained by 0.5 minus this area, unshaded area. Therefore, this is 0.5 minus this unshaded area is this area where xz takes values from 0 to 1. 0 to 1. Therefore, this is equal to 0.5 minus this is denoted by phi of 1. And the table value of this phi of 1 is 0.3413. 0.5 minus 0.3413 is 0.1587. This is the probability of any student scoring more than 75 marks. And there are 1,000 such students, therefore required is 1,000 into 0.1587, which is equal to 158.7. That can be approximated to 159. Next, third case. First, third case, between 65 and 75. Between 65 and 75. Very simple problem. Between 65 and 75 is this probability. P, where 65 less than x less than 75. If x is equal to 65, corresponding z is equal to 65 minus 70 minus 5. Minus 5 divided by 5 is minus 1. And if x is equal to 75, z is equal to 75 minus 75. 5 by 5 is 1. Therefore, writing P where 65 less than x less than 75 is same as writing P where minus 1 less than z less than 1. Both are same. 65 less than x less than 75 is same as minus 1 less than z less than 1. Minus 1 less than z less than 1. Now mark this area where minus 1 is less than or equal to z less than or equal to 1. This side half of the area under the curve and this side half of the area under the curve. This is positive z and this is a negative z. Z is equal to minus 1. It comes somewhere here. Z is equal to minus 1 and z is equal to plus 1 will come somewhere here. This is z is equal to plus 1 and this is z is equal to minus 1. The interval is from minus 1 to plus 1. Minus 1 to plus 1. Now split this interval into two subintervals. First interval is from minus 1 to 0 and then 0 to 1. Minus 1 to 0 and then 0 to 1. This minus 1 to 0 can also be written as 0 less than or equal to z less than or equal to minus 1. This is the interval. If you multiply this interval through by a negative sign, the inequality will be reversed. That is 0 less than or equal to z less than or equal to 1 like this. And this probability, this remains same. P from 0 to 1 plus P from 0 to 1 is twice P from 0 to 1. This P from 0 to 1 is denoted by phi of 1. Therefore, this is 2 into phi of 1. Therefore, this is equal to 2 into table value of phi of 1 is 0.3413. 2 into 0.3413 is 0.6826. This is the probability of any student scoring between 65 and 75. How many such students are there? 1,000. Therefore, required is 1,000 into 0.6826. That is equal to 682.6, which can be approximated to 683. Make a note of this. Let's move to the next problem. The mean weight of 500 students during a medical examination was found to be 50 kgs and the standard deviation 60 kgs. Using this, we can construct the standard normal variate, that is Z given by x minus mu divided by sigma. The mean weight of 500 students is found to be 50 kgs. Mu is equal to 50. Therefore, x minus mu is x minus 50 divided by sigma, and sigma is 6 kgs. This is what we call a standard normal variate. Now mark your attendance. I'll enable it now. Now you can mark your attendance. Z is given by x minus 50 divided by 6. Assuming that the weights are normally distributed, find the number of students having weight between 40 and 50 kgs. 40 and 50 kgs. First case. Second case, more than 60 kgs. Let's consider first case. Between 40 and 50 kgs. That means P where 40 less than x less than 50. This is to be determined. What will be the value of Z when x is equal to 40? When x is equal to 40, this will be 40 minus 50, that is minus 10 divided by 6. Minus 10 by 6 is minus 1.67. It's actually minus 1.666. We can approximate it to minus 1.67. If x is equal to 50, what will be the corresponding value of Z? Upper limit. When x is equal to 50, what will be the corresponding value of Z? 50 minus 50 is 0. 0 divided by any finite quantity is 0. Therefore, writing P where 40 less than x less than 50. Probability where 40 less than x less than 50 is same as writing P minus 1.67 less than Z less than 0. This is because when x is equal to 40, corresponding Z is minus 1.67. When x is equal to 50, corresponding Z is 0. Therefore, P when minus 1.67 less than Z less than 0 is equal to P when 0 less than Z less than or equal to 1.67. If you multiply this inequality by a negative sign, you get a 0 less than or equal to Z less than or equal to 1.67. That can be written as phi of 1.67. And table value of phi of 1.67 is 0.4525. This is probability of any student having weight between 40 and 50 kgs. How many such students are there? 500 students are there. Therefore, multiply this quantity by 500, you get 226. 226. Next case, more than 60 kgs. More than 60 kgs. More than 60 kgs means P where x is greater than 60. This is to be determined. And z remains unchanged. Z is equal to x minus mu, that is 50 divided by sigma is 6. If x is equal to 60, what will be the corresponding value of z? Z is equal to 60 minus 50, that is 10. 10 by 6 is 1.67. Therefore, writing p where x greater than 60 is same as writing p where z greater than 1.67. Z greater than 1.67. Mark this area. This side we have half of the area under the curve, and this side we have half of the area under the curve. Z greater than 1.67. Z is equal to 1.67 is a positive quantity from somewhere here. This is the area where Z is less than 1.67. This is the area where Z is greater than 1.67. And this area is required now. And this area is obtained by 0.5 minus this unshaded area. 0.5 minus this unshaded area is area from Z is equal to 0 to 1.67. 0 to 1.67, which is denoted by phi of 1.67. Therefore, we get 0.5 minus phi of 1.67, and table value of 1.67 is, I think, 0.4525, right? 0.4525 table value. Yes, phi of 1.67 is 0.4525. 0.5 minus 0.4525 is 0.0475. And there are 500 such students. Therefore, multiply this quantity by 500. You get 500 into 0.0475, which is equal to 24. So please make a note of this. We're running out of the time. I'll stop here and continue the next class. Thank you.